Welcome to Signal Ahead. I'm Alfred. Today's briefing, Theory and Foundations, Physics plus Math. Wednesday, June 17. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. There's a temptation, when you survey the theoretical physics and mathematics being produced right now, to treat it as a great unsorted heap of brilliance, black hole entropy here, octonions there, a problem about Galois groups somewhere off to the side, each item admirable, none obviously speaking to the others. And the casual reader of science news, scanning the headlines, will come away with exactly that impression, that the field has fragmented into 1,000 specialist conversations, each conducted in a private dialect, none of them load-bearing for the rest. I want to suggest the opposite. The most non-obvious thing happening in the foundations right now is not any single result. It is that the very notion of where the foundations live is being quietly relocated, from the physics to the bookkeeping. Let me explain what I mean, because it cuts across almost everything on the table. Consider the work attempting to derive the standard model gauge group, that peculiar product of symmetries that governs the particles we actually observe, not by postulating it, but by extracting it as the symmetries of an octonionic object, a kind of three-state system built over the strangest of the number systems. The octonions are the eight-dimensional cousins of the complex numbers, non-associative, awkward, long suspected of mattering, and long resistant to being made to matter. What's striking is the direction of the argument. One does not start with physics and reach for mathematics as a tool. One starts with an algebraic structure that is essentially forced upon you. The exceptional Jordan algebra is not something you choose. It is something that exists whether you like it or not, and one asks whether the physics falls out as a consequence. The gauge group becomes a theorem rather than an input. Now hold that thought against something that looks utterly unrelated. The effort to put 11-dimensional supergravity on shell simply by imposing certain consistency conditions, Bianchi identities, on flux densities over superspace, and then to reduce that to 10 dimensions by an operation called cyclification. The vocabulary is forbidding, but the move is the same one. The physical content, the equations of motion, the dynamics is being shown to follow from demanding that a piece of mathematical bookkeeping be globally consistent. The fluxes have to be quantized properly, the cohomology has to close, and once you insist on that, the physics has nowhere else to go. Geometry and algebra are not describing the theory after the fact. They are the constraints from which the theory is born. You see the same instinct in the more abstract corners. There is a program to categorify Gelfand duality, that classical and beautiful correspondence between commutative algebras and spaces, so that even the non-commutative, the genuinely quantum, gets a geometric shadow, a spectral stack assembled by gluing together its commutative pieces. And there is the patient internal reworking of Bayes-Serre theory, the study of how groups act on trees, recast so that it holds uniformly across sets, profinite spaces, any topos at all. In both cases, the ambition is to find the general machine, the one that runs identically whatever you feed it, so that what once looked like a fact about a particular object becomes a fact about a kind of object. And then, this is the part the newsreader will entirely miss. The same relocation is happening on the human side of the discipline. There is the matter of distilling 22 million problems in universal algebra into a compact cheat sheet, and a new collaborative challenge aimed at generating numerical data for the inverse Galois problem, the old question of which finite groups can arise as symmetries of number fields. These are not curiosities. They are the field beginning to treat its own production of knowledge as something to be systematized, automated, made global and consistent, the very thing it is doing to nature. The worry voiced about proposed changes to how grants are administered and the appearance of textbooks written with machine assistance belong to the same story. The infrastructure of thought is becoming a first-class object of attention. So here is the through line I want to set up for what follows. Whether it is black hole entropy emerging at second order as precisely the horizon area when an energy condition holds, or a cosmology that is stable for one matter model and violently unstable for another, or the localization of an action onto the tips of toric cones, the recurring discovery is that the constraints carry the content. Consistency, quantization, closure, descent. These are no longer the hygiene of a theory, but its substance. Over the next two stretches of our conversation, I want to test how far that holds, first by following the physics, where the constraints meet the cosmos and the black hole, and then by following the mathematics and the machines, where the bookkeeping threatens to become the thinker. The field is not fragmenting. It is converging on a suspicion that the deepest things are the things that cannot be otherwise. Let us see whether the suspicion survives contact with the details. There's a thing that happens when you stand too close to a body of research. You see the individual waves, a paper on black hole entropy here, a new characterization of the standard model gauge group there, a competition to gather numerical data on which finite groups arise as Galois groups. Each one looks like its own small event, breaking and receding, and if you're not careful, you mistake the foam for the ocean. The point of stepping back, of doing what we are doing now, is to ask what the water is actually doing underneath. What's the deep current? Let me offer a candidate, because I think there genuinely is one, and it's been gathering force for some decades now beneath the surface chatter. The current is this: across physics and mathematics, the action has been steadily migrating away from the objects themselves and toward the structures that relate objects. We have stopped asking primarily, what is this thing? And started asking, what is the pattern of relationships in which this thing is merely a node? Consider the work on the standard model gauge group emerging from the exceptional Jordan algebra. Now, you might expect the punchline of fundamental physics to be a list. Here are the particles, here are their masses, here are the forces. Instead, what you find is a characterization. The gauge group is described as the symmetries of an octonionic quadrit that restrict, in just the right way, to act unitarily on an ordinary quadrit, and within that, on a qubit. Notice the grammar of that sentence. It is symmetries within symmetries, restrictions within restrictions. The thing we call the forces of nature is being recovered not as an inventory, but as a nested condition, a constraint on what is allowed to act on what. The physical content sits in the relationships, not in any brute list of ingredients. The same current runs through a piece of work I find quietly astonishing, on flux quantization in 11-dimensional supergravity reduced to 10 dimensions. The headline result is that the full theory is put on shell, made physically true, simply by imposing certain symmetric Bianchi identities on superspace. And the mechanism of dimensional reduction, the act of going from 11 dimensions down to 10, is governed by something called a cyclic loop space. You don't reduce a theory by throwing away a dimension and seeing what falls out. You reduce it by understanding how the algebra of its symmetries, these Whitehead bracket structures, transforms under precise categorical operation. The physics has become, in a quite literal sense, the bookkeeping of relationships among relationships. And then there is the most naked version of the current, in pure mathematics, where there's nowhere to hide. Take the categorified spectral duality work. The old Gelfand duality told us that a commutative algebra of observables is the same thing as a space, that geometry and algebra are two faces of one coin. Beautiful, but the moment you go non-commutative, the coin loses its second face. There is no space anymore. And the response is telling. Rather than mourn the lost object, the construction builds a spectrum out of relationships, a stack assembled from the commutative contexts of the algebra, glued together by descent, by the discipline of how local pieces must agree on overlaps. The geometric object is not found. It is woven from the consistency conditions of its parts. You see it again in the internal Base-Serre theory, where a group acting on a tree is recovered as the fundamental group of a graph of groups. The information lives in how the pieces are attached, and you even see it, charmingly, in something as humble as Buckingham's theorem about physical units, the discovery that the meaningful content of a measured system is not the raw quantities at all, the speeds and pressures and lengths, but the dimensionless ratios you can form between them. The recent twist is that a machine can find those ratios from data alone by noticing that measurements under different scalings lie on a low-dimensional manifold. The system's behavior was never in the numbers. It was in the geometry of how the numbers relate. So that's the current. It pulls in one direction with remarkable consistency, whether you're localizing an anomaly polynomial on the tips of toric cones or studying the representation theory of W-algebras through the fixed loci of a torus action on a Springer fiber, or proving that a universe full of fluid is stable where one full of dust is not. In each case, the substance is relational, structural, conditional. Why does this matter beyond aesthetics? Because it changes what a discovery even is. When knowledge lives in relationships, progress means finding that two apparently distant relationships are the same relationship in disguise. The octonions and the standard model, the supergravity and the loop space, the gauge theory and its estual. Unification stops being a merger of things and becomes a recognition of shared structure. And that, I'd suggest, is the tide we ought to keep our eye on as we turn, in a moment, to where it might be carrying us. There's a phrase that surfaces, almost despairingly, in one corner of the corpus this week, the description of a certain approach to fundamental physics as the only game in town. It's worth sitting with that phrase because it captures something about the mood of theoretical physics that the rest of our material both confirms and quietly subverts. When a field declares that it has only one game, it is making a confession dressed as a boast. It is saying, we have run out of forks in the road. And yet, if you look at what's actually being produced, the actual papers, the actual moves, you find not one game but a teeming bazaar of them, most played in near total independence of one another. So the first thing to watch is this tension between rhetoric and practice. The rhetoric says the foundations are settled or settling around a dominant framework. The practice says something else entirely. Consider the sheer heterogeneity of what's on the table. Someone is wringing exact solutions out of a Liouville-type field on curved backgrounds using a clever auxiliary null vector. Someone else is localizing an anomaly polynomial at the tips of simplicial cones to read off black hole entropy. A third is reconstructing the functional form of a modified gravity theory from the dynamics of an anisotropic universe. These are not moves in a single game. They are different games that happen to share a vocabulary. And the unifying claim that one framework subsumes them all does very little actual work in any of them. What I find more honest and more interesting is the slow, patient effort to ask whether our oldest assumptions even hold. Take the result on the matter-dominated universe. For decades, it was understood that a certain cosmological spacetime is unstable when you model matter as dust, pressureless, frictionless stuff. And now a careful numerical study suggests that if you give the matter a proper equation of state, a little pressure, the instability vanishes and the spacetime becomes stable. That is not a flashy result, but notice what it does. It tells us that a conclusion we thought we understood was an artifact of a simplifying assumption. The dust was lying to us. And the second-order implication is sobering. How many of our other settled intuitions rest on idealizations we've stopped questioning because they were convenient? This is the deeper pattern I want you to watch for. The most consequential work right now is often not the construction of grand new edifices, but the careful interrogation of foundations we assumed were load-bearing. The black hole tidal response is another example. In standard general relativity, the love numbers, the measure of how a body deforms under tidal stress, vanish for a Schwarzschild black hole. That zero has felt almost magical, a sign of some hidden symmetry, and now people are perturbing it with higher derivative corrections to see exactly how it breaks. The vanishing was a feature of a particular truncation. Push past it, and structure appears. Again and again, the lesson is the same. The clean answer was the boundary condition you forgot you imposed. And then there's the question of whether physics is even reaching for the right tools. One of the more provocative threads concerns whether the symmetries of the standard model, that peculiar, almost arbitrary-looking gauge group we've been handed by experiment, might emerge naturally from an exceptional algebraic structure, the octonions arranged into a kind of octonionic quotrit. Now I am temperamentally cautious about beauty as a guide to truth. The history of physics is littered with elegant structures that turned out to describe nothing, but the move itself is the right kind of move. It refuses to take the standard model's strangeness as brute fact. It asks, what would have to be true of the underlying mathematics for this particular group and no other to be inevitable? So what should you watch for as these threads develop? 3 things. First, watch where simplifying assumptions get tested and break, because that is where genuinely new regimes of behavior are hiding, as with the stable Einstein-Euler cosmology. Second, watch the quiet migration of techniques across the supposed boundaries of the field, equivariant localization showing up in black hole thermodynamics, category theory furnishing geometric objects for non-commutative spaces, the very humble Buckingham theorem of dimensional analysis being reincarnated as a method for discovering hidden structure in data. Methods travel faster than theories, and they often arrive before anyone has built the grand framework that's supposed to explain why they work. And third, watch the language. When a community insists it has only one game in town, listen for what that insistence is defending against. Because the actual record, the actual papers, tells a different story, a field that is far more plural, far more uncertain, and frankly far more alive than its own official narrative admits. The foundations are not settled. They are being relayed, one tested assumption at a time, by people who are quietly refusing to believe that the questions are closed. That refusal, not any single result, is the signal worth tracking. The game in town, it turns out, is the asking. That's the signal for today. The noise will keep coming, we'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.